So the following handout is a summary of what you should have read in the slides and watched in the videos. We have the equations that we'll work with when we work problems for Boyle's law, Charles's law, and Avogadro's law. For Charles's law, you must remember that anytime you use temperature with the ideal gas law or Charles's law applications, you have to have your temperature in Kelvin. The relationship between your temperature in Kelvin and your temperature in Celsius is that your temperature in Kelvin is equal to the temperature in Celsius plus 273.15. I do expect that you have all of the digits in that equation, and that is an equation that you must know. So I would highly advise you to put that equation on your personal study guide so that you know it. As you work several of the gas law problems that you'll be expected to work, you should learn that equation pretty quickly. What we see with all this information is that Boyle's law gives us a relationship between pressure and volume set equal to a constant. Charles's law is volume over temperature set equal to a constant, and Avogadro's law is volume over moles set equal to a constant. If we combine all of these simple gas laws, that gives rise to the ideal gas law. And if you look at the ideal gas law equation here, you see that pressure times volume, which comes from Boyle's law, divided by moles times temperature, which comes from what we learned in Charles's law and Avogadro's law, is equal to the ideal gas constant, which is R. So PV over NT set equal to R is one form of the ideal gas law. PV equals nRT is the other form of the ideal gas law. It doesn't matter which form you know, but you must memorize the equation for the ideal gas law. R is our gas constant, and its value is 0.082057 with units of liters times atmospheres per mole times Kelvin. I will provide the value of R on your equation sheet. You must know how to use it, and you must also know the ideal gas law. When you look at the value of R, you see that I've provided it with the units. I will do that on your equation sheet. And the units are liters times atmospheres over moles times Kelvin. That is your reminder that your volume must be in liters, your pressure must be in atmospheres, your number of molecules must be in moles, and your temperature must be in Kelvin. So a lot of the problems we work with the ideal gas law will begin with a series of conversions to get to those units and allow us to plug into the ideal gas law. You also saw a discussion of standard temperature and pressure, and that is where our standard temperature is 0.00 degrees Celsius. Our standard pressure is 1.000 atmospheres, and we can set these conditions for an easy way to allow us to compare gaseous samples. And so you'll work problems where you're told those samples are at STP, and this is the information that you need to know in order to solve those problems.